Hello. Okay. So my name is Devin, and I work at a company named Smule, where I'm a senior operations engineer. And I gave a talk at BSDCan about Dtrace and a new tool I wrote and put into FreeBSD 11.2 called Dwatch, which hopes to make using Dtrace much easier. Well, when I got back from Canada in June, my bosses were so impressed with everything, they completely shunted me over to a new project, which is essentially big data. So I actually want to shift gears and actually slow down a little bit. In Canada, I had a whopping 97 slides, and I blazed through them in 60 minutes. Well, I've only got 45 minutes here, and we have no slides because what I have to show you doesn't work on a slide. So I'm going to start by showing you Dwatch and the Dtrace backend, and then take you into how we're using that to visualize the data for consumption by my peers. So Dwatch, if you execute it without any arguments, it gives you a really big usage statement. The reason for the number of options is because Dtrace itself has a lot of options. And so Dwatch actually generates Dtrace code. And so without much further ado, I'll give you a quick example and then show you what it's doing underneath the hood. So here I'm watching the execve probe in Dtrace. And here it's just spit out a bunch of programs that got executed, and who did the execution, the name of the program, the name of the PID, and the full execve args that were actually passed to it, to the system, to the libc call.
What command did you use again?
Dwatch execve. Even better if you just throw a -r on there. Sorry. Let me see if I can actually get some code to run here. Oh, just wait long enough. The box has Chef running on it, so I just wait long enough. Here we can actually see a little miniature process tree for each one of the executions. So sh executed asleep, xargs ran some timeout code, timeout ran some shell code, xargs ran some more code, all good stuff. But there's amazing filtering built into Dwatch in order to help you whittle down the fire hose. Now naturally, if you pipe this into grep, you're only going to get the one line. Well, every line has sh on it. Let's try grepping for a PID. Right, so a PID. Something that works. There we go. There we go. So this is not ideal. So I actually built in grepping right into Dwatch. So now whenever it finds that anywhere on the block, it will actually print the whole block as an entire item. There you go. Now I have rainbows turned on because I like them, but Dwatch actually has colors that it outputs that will help you identify why that block matched. So here we see that this block, which has this timestamp, matched because of the line argument to xargs. But what is this all doing underneath the hood? I have a -d flag which says don't actually run the code that I generate, but instead print it out on the command line. And so here, this is actual Dtrace code. And if I pipe this into Vim, Vim actually knows how to syntax highlight Dtrace. So this is actually the Dtrace code that Dwatch generated. And it's quite complex, and we plumb a lot of data from a lot of different places. But you didn't have to write any of this. You just gave me a single probe point, and I shoved it right there. In fact, I even just took the simple word of execve and I turned it into a fully qualified Dtrace probe for you before I put it in. So you can start to see how some of this plays out. If I say watch execve, put that into a file, make sure it doesn't exist. I don't know, nano sleep. That's the only difference. Well, there's a couple places actually it goes into. But that's not all. So I showed you dwatch execve, which is going to show you everything. I showed you how to whittle it out with regex. But you can actually insert Dtrace code that sets predicates for when these outputs fire. And that would be the -e code option. And so if I say dwatch, well, first of all, what's my shell? So my shell is 61866. Or better to demonstrate with a second shell. Okay, I'm going to watch this shell. Okay, so now I didn't tell it to print anything, but I get an event for everything that's executed. And yeah, there's stuff that runs in the background in my shells because I have a crazy bash profile. How crazy, you say? 3,000 lines, okay. But what I really want to show you today right, that's in Ashburn, not San Francisco. Right, okay. Is that I've daemonized some of these processes and written over 100 different profiles for glomming out specific information that is very particular to the probe that you're watching. You can actually list the different profiles that you can enact with dwatch-q, and then dwatch-X in order to execute one of them. So if I were to say, I want to watch IP, this gets a little noisy because this is a production server that's actually doing things. And also every time it spits out to the command prompt, that counts as SSH traffic. So that's, yeah, it's just a huge fire hose. Some of those actually output different formats. I have two different formats that are not human readable. I have Coarse outputs and Json outputs. The Coarse outputs are for driving Coarse, which is a visualizer that I showed during BSD CAN, which, quick recap. Show me VFS data from that host. So this is VFS information in real time coming directly off that host being fed from Dtrace. And so every time a file system element is touched, I show the program that's touching it. I can actually pause this. So there's file beat. If I click on it and hit V, it actually focuses on that. And if I hit space, then it resumes. I can actually hit tab and jump over to that SH. xargs, sleep, which is going away, and turn server. Okay, so that's cool. And what's going on in the background is this. So this is the format that Coarse consumes. It takes a timestamp and epoch format, and a pipe, and then the name of the program that's doing the touching, and a pipe, and then an A for add, M for modify, D for delete, a pipe, and then the path. But that's old news. That was last June. All of this stuff that I'm showing you actually is part of ports. Let's go here. So I have dwatch. This is our system, which is still running 11.1, so dwatch is a package. On 11.2 and above, it's actually built into base. But you see dwatch Coarse there. That's what I was using in order to generate that information. And dwatch JSON was just released last week, and it has new profiles for dwatch. Ah, screw it. Oh, that was a bad choice. Okay. So all of the profiles from ports that extend dwatch go into user local libexec dwatch, while the ones that are core that are in base are in user libexec dwatch. And there's 81 in base and 23 in ports, or something like that. Let's focus on the ones that are provided for JSON output. And so the first one I wrote was dwatch Json Net, which simply the output to my terminal here is SSH is affecting the output. And this is real time every single event. And so we see things like that's ascend, and lots of other things. I wrote these profiles intelligently so that I actually stuff all of the important information into clause local variables that you can use in order to prune the information to your liking. So you actually have an event, a family, a local, remote, local 6, remote 6, those are Booleans, the port, and the length. So if I want to say, show me JSON Net, but I only want events where this length is greater than 20. Okay, so now I won't get any events for anything less than 20. It's kind of worthless though. I can say exec name is not equal to SSHD. Might help preen things out, make things a little bit less noisy for me, at least. And so we started plumbing this information, and we started putting it into the visualizers and databases, and we quickly found that if you have over 10,000 people dumping information into your Kafka queue, which into the machine that's generating these stats actually, you quickly overflow you just inundate your database. So I wrote a new protocol, a new profile, and that would be Json Net Top, which is essentially like JSON Net, except it doesn't print out information real time. It waits 10 seconds, and it counts up the length. So we lose all of the individual sends, individual reads, we lose the binds, the attaches, the disconnects, and we just focus on send, receive, aggregate them into a counter, and then dump it out every n seconds. And so that looks like this. The default is probe 10s, but you can override it on the command line. A lot of features don't make sense for this, like doing a PS tree on it with -R doesn't make sense. It's disabled for this profile. And so here we have the length and TCP receive. These are the buckets that we actually build up over time, and then we dump them. At the end, we just basically dump out this JSON and then reset the counters. So I just run it by itself. Every 10 seconds, it's going to print out a single line of JSON showing me the global send and receive stats for this box. So here in the past 10 seconds, we've had 5,158 bytes that were received on UDP and 5,000 bytes that were sent on UDP. 0 over TCP received, and 368 bytes sent over TCP. Well, if you're going to take these stats and you're going to visualize them for production, you might not want to watch globally all of the traffic, but you might want to zero in on certain services, a specific PID, a specific process name, a specific port, or a specific remote IP address. So it's quite simple. I could say -T for test, exec name equals blah. But I actually made it a little bit easier than that. You just say -K blah. So here I'm actually going to say -K turn server, yes, which is an actual process running on this machine in production. And no matter how much data I give it over SSH, it's not going to affect it. No TCP sent, no TCP received. This box is actually our integration server. I can hop over to our production box. Let's see here. So I'm pressing space and back, which would normally generate a bunch of TCP data, but I have this Dtrace only watching one process. So TCP received and sent is generally very small, almost none, because all the traffic to this box is on UDP to that process. If I wanted to override, I could just say tick 3s. And now I'm going to output the stat every 3 seconds instead of every 10 seconds. Yes. 1, 2, 3. It's not working, right? That's better. All right, slight bug with tick. Let's see here. So once you get this data, you can put it in a file and stick FileBeat on it. And so we have FileBeat running, and we have that configured over here. It's a YAML file, and it basically says, there's only 2 fields here that really matter. Here's the list of servers that I'm going to send that to that are running Kafka. Here's the topic that I'm going to dump it into. And where are the files? At the top, there it is. There's the file I'm going to watch. So you tell it which file to watch, a couple of other ancillary settings, which are mostly defaults. The servers to dump it into that are running Kafka, and the ports, and the topic. So now if you go over to another machine, you can actually then dump the Kafka queue like a fire hose. But it's going to contain that Dtrace data from all different nodes. And so we actually use the Kafka software. There's a client that comes with Kafka called Kafka Console Consumer. And that guy, if you just give him the topic and give him the path to what's called a Zookeeper instance, which says, oh, that's these Kafka machines, it will go and fetch the data and dump it to the command line on standard out. So if you, I actually wrote tools for this. What did I do? Merge. that looks like this. No, I guess just that. So you tell it the topic, which is cfire turn, the zookeeper, and you'll have some research to do if you want to learn all this. But so far we're talking about Dtrace takes data from the kernel, dumps it in a file. FileBeat takes it and dumps it into Kafka. Kafka can be plumbed with its own consumer on the command line, and I put that into a FIFO, which is then processed by Telegraph. Telegraph works with InfluxDB. It's actually made by the same people. So the net effect is so let's just go back to that one box. So this file, yeah, I have fancy stuff, I'm sorry, is being generated every 10 seconds a new line ends up. That's picked up by FileBeat, sent over to Kafka. When you dump it, it looks like this. And this is coming from multiple nodes. So we've got A33, turn 3, turn 2, turn 1, BE1. Yeah, there's at least 20 different hosts dumping these Dtrace stats into Kafka. And then we just use this command, that Kafka console consumer, to dump them back out. So we've aggregated the Dtrace stats into a central collector, and now we're dumping them out. The next step is then that goes into Influx via Telegraph. Unmodified, Telegraph is just a tool that has multiple ins and multiple outs. You can say, take data from a file, put it in Postgres. Take data from Postgres, put it in a file. Take data from your kitchen, put it in the living room. No, I can't do that, sorry. But once you have the data in this format, you can do two interesting things. You can put it into Grafana, but you can also put it in a tool called Visceral. And so this tool actually shows us the real-time flowing of data from all the different nodes in our production stack. And so we actually have a active-passive failover system here. So this one, cf1.sg, all the data is going to a6.sg. If a6.sg goes down, all the data will actually come down here to a7.sg. We haven't put the load balancers in place yet, but once we do, we'll actually be able to see multiple paths being exercised. Scrolling down here, you can see I've actually put time series data below the visceral object. And this allows us to track over time. It's like, okay, let's see here. Well, all the paths are actually being exercised right now. But if one of them hadn't, I would probably go down here and be like, okay, San Francisco, why are you not working? But it is right now. So there's the send and receive for San Francisco. If you're familiar with Grafana, you might be wondering how we got this visceral object in here. It's literally just an iframe to this document right here, which looks like this, and when you pull it up full screen. Now I'll show you what this actually looks like on the back end, because it's really cool that you can actually generate these with fake data and get a sense of what you want to visualize before you go and plumb Dtrace for the data and then hook it into the gamut of FileBeat, Kafka, Telegraph. Now, Visceral itself is made by Netflix. It was released in 2015. It's a node object. And this is like the only node I use because it's cool. You want to use it. So I jumped over the hurdle of not liking Node. So this one here is cfire turn net prod. And so it's literally just a little tiny function for loading JavaScript asynchronously. And then your static definition of what are the nodes and what are the connections between the nodes. So the internet goes to CF1. Internet also goes to CF1.ash. Those are the VIPs. And then from the VIPs to the nodes, from the nodes to the VIPs, the backhauls, and the VIPs to the internet. But this is fully fleshed out with production data. That is, it has the AJAX command at the top. It has the AJAX function, load JSON, which is shoved into a timer and called to update the data. So we actually have the CGI right here, where the data, where the AJAX, where the JSON data is loaded. And it looks like that, which is literally just the last line of the file that I'm building from my Kafka consumer. Sorry, Emacs key bindings is killing me. Yeah, it's written in Perl, but it's just because it was quick and dirty and easy to do. Use the file read backwards module in order to read the log file, read the last line of the log file. That's it. And I did it that way because it's much more efficient than running tail. It literally reads the file backwards. Actually, it does an EOF to the end of the file and reads backwards for the new line and then spins out the last line. So you can have a terabyte file and get the last line in under a millisecond. If it's cached. Let's see here. Visceral. Okay, don't VI directories. I mean, you can, but. Okay. So let's pull up one where we can just play with it a little bit. Okay, so here's one. And all I've done is just basically set up a bunch of nodes that go to one point. This is actually part of a project where we're actually going to centralize this one database backend, but we wanted to see what it would look like, so that way when we actually plumb the data and actually starts filling the graph, we then are ultimately given a time series that we can go back to in order to figure out, did we scale this out properly? Did we correctly guess the requirements for this service? But here, you notice there's no JSON. You don't need that. You don't need the load JSON function. Visceral, you just basically give it this data function, this data JSON format. You give it a name, a renderer, whether it's going to be a global format or tree. They actually have different layouts you can do. And here, I'll just go and add a new node. And then set up a new connection for it. Okay, just by doing that and refreshing, I now have my fun node. But it doesn't have any data, so let's just give it some fake data. Let's give it a lot of data. All right, that's fun. But you can actually say I want some semblance of normal, warning, and danger. So you can actually give it red, green, red is kind of bluish white, and yellow. So you can think of a lot of different ways you can use this visualization to say, oh, well, drop packets or IPv6. I actually have taken to like saying coloring IPv6 packets as green whenever I need it to see that visualization. So super simple. Visceral gets you up and running real fast with fake data. And it just takes a little bit of ingenuity, like getting that load JSON function into your code, and then calling a CGI, which gets the last line of data which is aggregated off of your Kafka fire hose. But I want to show you something even better. Now you need 2 terminals to do this. So for example, I'll just launch NC to listen on port 9000 here. And so I'm going to give, this is like a live demonstration of what we were doing to limit the data. But I want you to be able to watch multiple things at once. And more so, I don't want you to have too much of a hard time doing it. So I made a third animal. And that would be Json Net Config. And that allows you to define a config file with the tests to get the parameters all as one big blob. It's just one single Dtrace running, taking 21 megs or less of RAM, almost no CPU, and it's going to give you all the data you need. Now, if you just run it by itself, it's essentially no different than dwatch JSON net, net top. So every 10 seconds it's going to give you a line. Except that I've actually configured it for some fun stuff. And so go look at the config. This is all part of the package, by the way. QLX dwatch JSON. How about package? Sorry. I don't know what's going on here. Oh, thank you. Thanks. And so you got a sample right there. So you just would copy the sample to non-sample. I've already made some customizations in here, which is that I don't want the big global TCP received, TCP sent, UDP received, UDP sent to catch anything except for turn server, which is the software running installed by turn server. It's coturn, yeah. And down here, I have this, all I have to do is define a variable named Redis. And the test for it is this remote is equal to 104.254.205.209. Anytime the turn server application sends any packet, whether it be UDP or TCP, or receives a packet, whether it be TCP or UDP, from that address, it goes into a different bucket. And so here, just running the command, it slurps in the config and does your bidding. Is that at that 10-second interval, it's going to give me the TCP received globally, well, for the turn server, the TCP sent by the turn server, UDP, Redis, TCP, and Redis UDP. Now, we haven't actually made the Redis backend active yet, so that's why it's all zeros. But we are preparing to feed this, which I've already taken and put into a dashboard. So it's ready to go. All I have to do is go and change the turnserver.conf file, point it at a Redis backend instead of a local SQLite database, and boom, data will just start showing up. And so it's not active right now, but the moment it does, this data will just light up, and then all of our assumptions will be confirmed that, hey, it's working, and we know what the bandwidth requirements are for all of these hosts slamming our Redis server. Currently, office bets are that we need something somewhere between a toaster and a fridge, or maybe an Apple Watch would work, but yeah, so we're all taking bets, and this is kind of fun to look at it that way. So Visceral also has a global view, which you can use in order to kind of parcel out at a higher level. So here we've just said, okay, show me all the traffic for Ash Relay, SG Relay, San Francisco Relay, and India Mumbai Relay. We can proportionally tell from the flows that are going on right now that Singapore is getting 47% of all of the traffic when it comes to relay traffic, which is co-turn traffic to the turn server process. And Mumbai is getting a scant just 1%. But hey, no errors across the board, that's good. And we can see over time, actually, if I slam this out to 24 hours, it tends to follow the sun. So we could see the red, which is Singapore, and Ashburn, Virginia, trading off for the top traffic here. We also put some clocks on the left-hand side so that we can kind of see what's going on there. We've done more interesting things, like mapping out to regional internet registries. So we take the incoming IP address and we map it to an RIR, which is one level above ASNs. Basically, there's only 33 RIRs registered with IANA when it comes to the whole internet when it's on IPv4. When you get to IPv6, there's even less. There's like 12. So if you are willing to write a little bit of code, I wrote mine in awk, because I'm crazy like that. I write everything in awk. I mean, literally, my Kafka consumer is like 3,000 lines of awk. It's crazy. But it's fast enough if you know how to use awk. We're actually getting 50,000 lines a second processed through awk. It's pretty cool. But we could tell which regions are most active. And this is just a day-night map. And I got tired of looking at a bunch of clocks and I said, well, what do you really want to see? We want to see where it's dark. Okay, problem solved. So I'll just go ahead and put that up. All right, so I'd like to use the last 10 minutes for questions. And also, I'm also open to willing to sharing anything about dwatch or dtrace, general questions. It doesn't have to be about this stuff. So, is there any questions?
It's awesome.
Oh, thanks. Thank you. Somebody want to see some more Coarse?
Yes, please.
All right, okay. Coarse is always the crowd pleaser. So, Coarse can be installed on your Mac through brew. Just brew install Coarse. You can install it on FreeBSD, but you need the whole X11 set. So I much rather prefer to just SSH into the FreeBSD box, send the Dtrace data back to Coarse running on my Mac. There's this gwatch utility, which I actually just copied to my Mac. So you install dwatch-Coarse on your FreeBSD box, and then you SCP, the gwatch utility to there. Is it an SBIN? I forget where I put it. Yeah, it's SBIN. And gwatch actually can talk to the remote machine for you. So you can actually just say the profile I want, and then either -L for the local machine or the remote SSH host. You can actually query what you can watch remotely. So what is it? -Q, just like dwatch, and then the host. So this is going to go out to N plus FreeBSD. It's going to tell me, it's going to tell me which gwatch profiles are installed that I can invoke remotely. So I can watch net. So this is real-time networking. All right, let it quiesce a little bit. Okay, let me get another window up. Put this one in the background. It didn't end up doing the NC stuff, but that's fine. Okay, let's see here. What should we do? Let's go to N plus FreeBSD. How about this? Let's type W a few times. Apparently W uses UDP, so those are queries against the name server. And you could do like timeout 5 seconds, shc while do W done. Just spawn a crap ton of W's for 5 seconds. Yeah. It'll take a little while for them to quiesce. There they go. They're out of the way. All right. Good stuff, good stuff. But again, you know, a lot of people look at Coarse and they're like, oh, this is great for watching movies or creating movies. But I actually think it's better than that, because you can actually pause it and rewind it, fast forward it, without being in a movie, and without actually being in the MPEG. It actually is somewhat of a debugging system. So, for example, here's all the system calls. They're being hit in real time by the program that's hitting them. And so I can pause this and zoom in and zoom out. And there's usually a little time marker I can use to jump back and forward, but I've disabled it. I can't remember which key re-enables it though. You can enable the stats for the actual rendering of Coarse. You can enable, what is it, the farmer's plot? V, 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 Z, Z. You can adjust the gravity. Turn on the, E, E, F, G. Turn off the users. Those are just the syscalls that are being hit. H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. Oh, yeah, turn on rostering. Yeah, it's interactive. You can do a lot of things with it. It's not just for making movies. More importantly, though, you can actually give gwatch a test as well, I believe. Here, it's dwatch extra options, dwatch. I can't remember how to do this. So what you can do is go to the box. Well, not that one. And so say you are wanting to do something like this. Well, I made these videos showing the build world, different build worlds. Let's see, let's do J8 versus build world compare. There we go. And in this one, I took two videos and put them side by side and time synced them so that I could actually watch what a build world-J1 looks like versus a build world-J8. Is there a way I can go full screen? Right, so in the end, the most important metric is it takes 4 hours and 40 minutes to do a -J1 and 1 hour and 4 minutes to do a -J8. But I actually wanted to see it. Well, the Coarse visualizer cannot keep up with the build world. So the appropriate thing to do is to do this. On a FreeBSD box, what was I doing? I think I was doing file system. Right, so Coarse dash, actually, is this, no, this is proc. These are processes being forked. Makes and SHs and CCs and stuff. Okay, Coarse proc. Okay, so this is the process accounting system in real time, but in Coarse format. And so you log this to a file, and then you can pull it back out. Okay, so let's just put this in a file. Timeout 10s. Put it into some file. Okay, cool. We got some data. All right, so dash little l and the log file. There you go. So generate it offline, put it in a file, bring it back, and then render it. Or, you know what? I needed to go backwards and forwards in time, which again, was it less than? Can't remember. But I can always just relaunch it and watch it again. These are the Coarse options. Auto skip, highlight users, bloom intensity, log format, custom, dir name, depth, file name. Yeah, I can't remember which one to enable all of the options, but there are a lot of options. And you can actually set like this environment variable Coarse opt, which if you want to set all the options you want, you can. It will actually also help you turn that log file into a movie. So say you want to just, oh, actually it was doing it without my, yeah, unless you pass -n, it will actually automatically turn it to a movie. Let's see here. Let's see, taking a log, turning it to a movie is -r, render output. -r l some file. All right, so this is actually running it. It's running the movie. In the background, we have ffmpeg compiling the movie. So when I'm done, okay, it's actually hit the end of the log now. It's done. Done. Open gwatch mp4. There we go. Pause. Fast forward. Maybe go twice as fast. Yeah. Cool. Really simple stuff. Cool. Anybody? Any other questions? Excellent. Yeah, down to the minute. All right, cool.